Hello and welcome back. In today's video, we're diving into an exciting project which is going to be useful for people that are developing Airflow systems. Airflow is by no doubt one of the best orchestrating software out there. Others are good as well, but Airflow is one of the leading orchestrating softwares. The challenge you usually have is how to deploy this from your local system into the cloud environment or into a production environment, production system. Now you have several ways of doing this. You can either use EC2 instance, the EKS or ECS, as you probably know is the Elastic Container Service or the Kubernetes service, whatever works for you. But in the real time, in the real sense of it, at the end of the day, what you have is you deploy it somewhere and then you manage your code locally, push it to maybe some repository, and it syncs into whatever cloud provider, which is your production environment that you deploy it to. That's usually the way it is in production. Now, what happens is we're going to be linking Airflow to Apache Kafka. And the reason for that is we're going to be going into a log processing. So think of a website that produces or customer visits that. You want to develop some models, you want to understand the behavior of the customers, the churn rate and drop rate and stuff like that. You can do so many things, but to keep things simple, people comes to your website, you want to understand the behavior pattern or whatever the buying pattern of these users are, then you ship those logs into Kafka. You have some producer at the back end that collects this information, ships it into Kafka. Then Kafka helps you to do, maybe through the VI consumer, helps you to do the aggregation and the manipulations and stuff behind the scene, and then pushes it to somewhere else, maybe some DB or whatever it is. But in our case, we have logs that are shipped from our website into Kafka. Then from Kafka into Elasticsearch, we index it. Now the good thing about this is if you want to do some searches, it's way faster with Elasticsearch by default. And then you can do some anomaly detection, behavior analytics, employ some machine learning model directly on this data that is on Elasticsearch. The good thing about all of this is it is free. You're not going to get charged for using the Elasticsearch or you're using the Kafka cloud. The only charge you are going to get is on MWAA because it is not free. And for the sake of this project, you're going to get charged maybe $0.29, which is about 29 cents per hour. So which is good. So if you spend like 3 hours on this course, you're going to have maybe 70 cents rather. So in that case, it's really useful in that case. So once you are done, you just delete the environment and you're good to go. So enough talk. Let's go into the architecture of the system and see what that look like in the high level. So what we're going to have is the system architecture is as simple as this. We're going to have our code that is shipped into Apache Airflow. Now, don't forget, I said you're going to code locally, push it to the repository to MWAA, which is Apache Airflow here. But the good thing about this is things like secrets are going to be taken care of automatically with AWS Secrets Manager. So you don't have to worry about the secrets from your Apache from Kafka cluster or Elasticsearch secret keys. You're not going to worry so much about them. They're going to automatically be handled with the secrets manager here. Then you have the CloudWatch. So if you want to see what goes on behind the scene or what's going wrong or going right or whatever it is, or you want to inspect your logs, you can go into CloudWatch for that. Now, the good thing about all of this is even if you have the URL for my system, you can't sign in because it requires a single sign-on as part of the security. So I'm going to have a single sign-on for this application, so you don't have to worry too much about setting up the username and password. Once you log into your AWS cloud, your single sign-on kicks in, and you can easily connect to your Airflow instance on MWA by default. Now, behind the scene, just a little bit lower than this, we write the code that produces the logs, which is probably consuming from our website or producing from there into Kafka. Now, the good thing about Kafka and in here, we're going to be using Confluent Cloud. Confluent Cloud allows you to have all of this by default, so you don't have to worry too much about visualizing what's going on in your Kafka cluster. And if you don't have an account before, they give you $400 credit to use for free of charge. So all well and good. So with that, we have a Kafka cluster that can be used in here. Then you have two ways to go from there once data gets into Kafka. We can either use the sync connector from Confluent Cloud, or you index it via consumer with Apache Airflow directly. So you stream this by consuming this from Kafka and streaming to Elasticsearch. That will be clear as we go along. But yeah, that's one way to go. But you can also use the sync connector directly, and which index the data inside the topic into Elasticsearch automatically. And once you get into Elasticsearch, it's free reign from there. You can go downhill on Kibana, connect it to any other system for additional processing, or even connect machine learning model for building models on Elasticsearch. But that's the way it goes. Now, before we go into MWAA, for those of you that this is the very first time you are working with MWAA, this is the architecture of how MWAA look like. This is straight from AWS, so you can just Google Amazon MWAA architecture and you have a copy of this. So what happens is, behind the scene, you have the service VPC, which is these are private AWS proprietary softwares. In here, you have the DB proxy, which connects to a DB that you can have access to. By what that means is Apache web server that you're using is connected to some DB behind the scene, which is usually metadatabase. Then you have a web server which is exposed via an endpoint on single sign-on, so don't worry about it, it's secured. Then on the other side, which is the customer VPC, you have the workers and the schedulers, which is exposed on the customer VPC. So you have access to the number of the schedulers you want to have, the number of additional workers you want to have, and stuff like that. And on the other side of things, you have the CloudWatch for visualizing the logs. You have the simple storage service, which is S3. You have the simple queue service, the key management service for KMS. So if you don't want to use the default the key management service that is usually gets shipped in with AWS services, you can use the key management service that you create by yourself, and you have extra layer of security in there, which is usually good. For the SQLs, if you want to employ the services of any queue and all that, you can do that with that. So that's pretty much how the everything wires up. Now let's go into the code and see what that look like and start doing the do. Okay, so I'm going to create a new project. I'll call this project maybe I should just reduce this a little bit. Yeah, so I'm calling this MWAA project. Yeah, so I'm using Python 3.9 for this. The reason for this is simple. You just need some ID. It could be Notepad, it could be anything that helps you to put your code in an organized way. So that's what I want to do basically. So once you start up the project with PyCharm, you automatically have the VNV. So if you want to create that, you can easily just go into the terminal. So far you have Python installed, just say Python -m venv, and this creates your virtual environment for you. Once that is created, you source it .venv being activate. But if you're using Windows, usually it's backslash without the source. So it's just like Windows like this. You have backslash being activate, and it activates the virtual environment for you. Good. Now let's get into the real deal of it. So we make a directory. Here we call it DAX. So this is where the code is going to be. And then we are going to have another file, which is going to be the requirements.txt. So we'll get back to that shortly, but let's get started with the DAX first. So we're going to have two DAX, one for producing and one for the consumer. Yeah. So let's create the first one. We call this log producer.py. Now the producer could be, it doesn't have to be faking things like we'll be doing, but you can just generate this as directly from your website. Okay, so in our case, we'll be needing a couple of things. If you do pip install, we'll be doing Boto3 which is going to be useful when we want to connect to MWAA resources for keys. We're going to need faker. This is for faking things like IP addresses and stuff like that, and randomization. Then we're going to be needing Confluent Kafka. As well for connecting to our Kafka cloud. And finally, we're going to need Elasticsearch. So those are the 4 major libraries that will be used in this video. All right. So once they are installed, the next thing is just to get started with that. And so let's get started. So I'm just reducing this and increasing the size of this. So just increase the size a little bit to, yeah, 22 seems fine. Good. I'm using 22 as my size. So let's create our first DAG for producing. So we start with the first one. So that will be our log producer. So in our log producer, you just need to bring up the regular style of Apache Airflow. So you can just say from Airflow import DAG, which is our normal DAG. Then from Airflow, I'm going to just disable my auto completion. Then operators dot Python. Now, if you want IntelliSense to kick in, you might need to install Apache Airflow in your system. So in my case, I want that Apache Airflow. So it's going to install Apache Airflow, and IntelliSense can kick in, so I won't see all these red scribbles anymore. So while this is going on in the backend, I'll just continue, and then we're going to need to import from Confluent Kafka the producer. So from Confluent Kafka, so import the producer. So the producer is going to help us to do that. So let's start with the simplest one now, which is the faker as well. Then from faker, import faker. All right. So for fake, you just have fake equals to faker as it is. And let's get our logger into the picture. Import login. Then we just have logger equals to login.getLogger for the name. So as much as possible, we are going to keep this as very professional as possible. So in our entry point, we're going to have more like a DAG, yeah? So usually you have a default argument. So default argument equals to a JSON object of owner. It's going to be data mastery lab. Then depends on past. We've actually discussed this before. So, but depend on past. If you enable it, it's going to run depending on the last job, if it's successful or not. So email on failure. This is not necessary. It's optional. And I'm going to retry once. So retries is going to be 1. So let's just do it as 1, and then retry delay. It's going to be time delta of seconds or 5. Yeah, you can increase this if you want, but if something fails, just retry it after 5 seconds, and if that fails as well, just stop. Yeah. So let's create a simple DAG. So we have our DAG equals to DAG, and then we get our the DAG property, which is our DAG ID. So we're going to have log generation pipeline, and that will be our DAG ID. So let's get in our default argument. So default args is going to be default args as it is. Then if you have a description, which is going to be what this particular DAG does. So it's to generate and produce synthetic log. Basically, if you want to use the actual log, then you have to give this a producer directly from your website. So I'm not going to be exposing my website to this for the sake of security. So for the schedule, we want to be running this every 5 minutes. So it's not too heavy and not too small. So every 5 minutes of every day, every hour, every minute, and every month. Yeah, you can check this out on crontab guru if you don't know how to work with it. So it's simply as going to crontab.guru, crontab.guru, and you see if you want to change anything, so at any value, you're using minutes, hours, day, month, and day of the week. Yeah, so I'm using this. So every minute I'm saying asterisk / every minute. So it says every minute, so run this every 5 minutes of every hour, of every day, of every month, and every day of the week. I hope that makes sense. Good. So that's what's going on in there. So for the start date, you have the date time, which is going to be 2025. Today, I'm just going to import this name. Yep. The month is January, and then the day is 26. Then the catch up is very important. If you wanted to, if in case you miss out on any of the previous days, then it's going to start processing from whatever start date you put in here and catch up from there. So in some cases where you miss any of those dates, let's say you run 26, 27, and you didn't run 28, 29, then on 30th, it's going to run 27, 20, 28, 29 that was missed. Okay, that makes sense, hopefully. So we have the tags of logs, then Kafka, and then we have production. Okay, and the reason why I'm tagging it as production is because it's actually in production environment. So if you want to use it in dev, you can tag it as dev, so it's easy to identify them. So we have produce log task. So to produce the logs, you have a Python operator that we brought in before, and that would be having a task ID of generate and produce logs. As simple as that. The Python callable is going to be produce logs, which we don't have right now, and the DAG is going to be DAG. Yeah. So let's get in our produce logs. So just above this, I'm going to have produce dev produce logs. Now inside here, I'm just going to open and close bracket, put in some context in here just in case you want to pass some context into that. So what we're going to be doing in this particular function is to produce log entries into Kafka. Now the way it works is we need to connect to Kafka before we can produce, and to do the production is quite simple. But you need to make sure that you have the right connection to Kafka to do that. Now, this is where it gets a little bit dicey. So if you want to use Docker in this case, you have to connect to your local environment or wherever your Docker is deployed to. You get the IP address and the port you expose your Kafka on. But in my case, I already have Kafka set up on the cloud, and I will show you how to do that. So before we start connecting to this, let's go through the Kafka setup so we can probably connect to it. So we go back to our browser here, and I'm going to go into Confluent Cloud and try to log into that. So I already have an account. I call this Ceres. So it's trying to log in. So if you don't have an account, you just need to log in. So but if you do, so if you don't have an account, you need to create an account, and you're going to provide your credit card details, and you have free access to $400. In my case, I created an account a couple of days ago, and if you look at this, I've just used $11, which is all of this, which is really good because it's quite cheap and relatively affordable. And by the way, I'm not using my credit card for this, so it's using the credits that was given to me. You see, I have $388 remaining, so which is good. So if you just want to test things out, it works just fine. Now to create a cluster, you go into the environment, and they give you an environment by default, which is the default environment. But if you want to have another environment, you can easily create another environment, which is you can use the free one, or you use the advanced one, and you can get a better understanding of what the capability look like in production environment. But in our case, essential is fine, which is free. So once that is created, simple as this, is just to give it a name. So let's call this MWAA production. Yeah, and then we create a free environment. So it's going to create this, and then automatically you have everything in here set up. So in our case, the cluster name is going to be cluster 0. We don't want that, so we'll call this MWA cluster. Well, it might not be MWA cluster, but in our case, we just use MWA cluster. You can change it to whatever you like. So this is great for most production ready extended feature set, which is 0.75 per ECKU per hour. So I think that works just fine. I'm going to be using AWS so for reduced latency, because if you use a different region or probably a different provider, there might be just a little bit of a tiny latency in there. Public is fine, encryption is automatic, and then we just launch the cluster. Now you have the cluster set up for you automatically. So in this cluster, you have access to MWA cluster. You don't have anything here just yet. So for you to connect to this, you need to get the API keys and then create a key. So in API keys, then it gives you access to either creating an account, which is an API key for your user, which means if you have access to the keys, then you have access to all of the services. Alternatively, if you want to just create API key for specific service accounts, then you can do that. But in my case, no need to get things too complicated. We just stick to my account key, so that should work just fine for me. So as it is, I just click on next, then it gives me an access key and a secret key to continue. Don't worry, I'm exposing this because I'm going to be deleting this afterwards. So the entire cluster is going down once this video is recorded. All right, so you can download and continue to keep a copy of this secret in your local system, but we're not going to be doing that. So what we're going to do, however, is to go into our AWS console and go into the secret. So we are going to be storing a new secret, and in here we're going to be using you can use the RDS or whatever it is that you want, but I'm not going to be using any of this. I'm going to be using another type of secret, and the reason for that is simple. This secret is going to hold all the secrets that we're going to be using for this project at the end of the day. So we're going to start with the first one, which is the API key here. So I'm just going to change this to so I'm going to call this Kafka SASL username, and that will be that. Then we have Kafka SASL password, and that will be the second one. I guess you don't need cron tab guru anymore, so just paste this in here. So those are the two keys for our APIs, which is good. Now to get information about our cluster, we can actually go into the cluster settings, I believe, and you have the bootstrap server here, which is the one I was looking for. Then here you can go back here and create a new, just like here, where is it? Kafka bootstrap server. Yeah, one server is fine. So in case you have multiple servers or multiple endpoints, which you don't need really because you're in production, so one single server just works just fine. So you have the bootstrap server, the username and password, and that is enough for connecting to Kafka cluster on the cloud. Now we do the same for Elasticsearch, so you can just go to Elasticsearch, and it's going to try and ask me to log in. So I'm going to log in with Elastic Cloud, and I'm going to create an account. If you don't have an account before, you can create it directly. So I'm just going to log in there. So once this is logged in, you see that I have an Elasticsearch endpoint in here. So I'm going to be using this Elasticsearch endpoint. So I'll just copy that and put it inside my secret. I'll call this Elasticsearch URL, and then I need to have an API key, yeah, for my Elasticsearch. I didn't copy them, so I just create a new one and call this YouTube key, and then apply expiration date, which is going to be in 2 days, yeah, and create an API key. So the encoded API key is here. So for my API key, I just copy that, and in my secrets, I'll call this Elasticsearch API key, and I paste it in here. So I have 5 secrets inside this particular secret that I'm creating in here. So the encryption key that I'm going to be using is AWS Secrets Manager. But if you want to use a different key for the encryption, you can actually create it by yourself by going into the KMS, which is the key management service that helps you to create a new key and use that. But I'm going to be using the default secrets manager here. So I just next this, and the secret name is going to be called this MWAA secret underscore version 2. This contains keys to Kafka cluster and Elasticsearch, and this is going to be YouTube, and it's going to be production for the 2 tags. So I just next that. So if you want to rotate this, let's say every day or every month or every whatever the frequency of rotation is, you can add that to that, but that's not needed. So the good thing about this is if you don't know how to connect to this, if you're using Java or any other library here, you have some sample code that helps you to do that. So for Python, this is how you can connect to it. So you might want to copy this somewhere, so it's easy for you to just create a function. We have a function that does this automatically, by the way, so you don't have to worry. We're going to get in there shortly. Then we store this. Now in here you should have MWAA secret, which contains the secret to Kafka cluster and Elasticsearch. So one secret takes care of all of the credentials that we'll be using in this video. With that said, let's go back into the code. Now we want to connect to Kafka. So to connect to Kafka, we need to get our secret to extract the secret credentials that we just saved in our secret. Yeah. So we have secrets. It's going to be get secret, the function that was shown to us on AWS. So I'm just called this MWAA secrets underscore v2. Yeah. Let's create a function that helps us to retrieve that. The same function that we copied from AWS, but a better one. So we have dev get secrets, and here you are going to have a secret name, secret, if I can only type secret, yeah, secret name, and then we have our default region, so it's going to be US East 1. Now this helps us to retrieve secrets from AWS Secrets Manager. Yeah, and to do that, I just need us to create a session, which is going to be our boto3.session, and we create a session from there, and we can extract data from our client, which is a session.client, and the service name is going to be secrets manager. Yeah, the region name is going to be the region name. So if you have a different region, this also works just fine. Just pass it in there. So the response that we get is going to be client.getSecret, get secret value, and that would give us the secret ID of the secret name. Good. So once we do that, we do a JSON load to extract that from there. So we have return JSON.loads, and we just need to import JSON. We response, and then we have secret string, yeah. And that's all we need to do here. Just close this up. Let me see. Response, then return that. Good. Then let's just handle the exception. If there's any exception, we just say logger.error. Then we say secret retrieval error. Then you raise the exception. You can raise the error directly, but I'm just logging the error, then just cancel that and we should be good. Okay, now going back to our producer, which is the produce logs, we can just easily from here, we have our secrets extracted for us now, but we need to get them correctly. So Kafka config is going to be for connecting to Confluent Kafka cluster or any production environment that is secured. For that matter, you need to have a bootstrap.servers, and in here you're going to have your secrets, yeah, which is the one you just fetch from MWAA. So we have Kafka bootstrap server. We're not using S for the bootstrap servers. Okay, then you have security.protocol, and you have SASL.SSL, and the reason for that is a secured connection. Then the SASL.mechanisms is going to be plain, so it connects through plain mechanism. Then you have SASL.username, so you get that from the secrets as well. So we have Kafka SASL username, then SASL the password, you have secrets Kafka SASL password. The session timeout, session.timeout in milliseconds is just 50,000. Yeah, more like a minute in milliseconds. Yeah. Okay, good. So that's 50 seconds in milliseconds. So the producer connection is going to be producer. So we're just getting our producer. So you can actually create a function in case you want to write unit tests for this. Maybe we should do that. So you can say create Kafka producer. So we have Kafka config. In that case, we need to create a function that does this for us. So just above here, just going to have dev, and we're going to have config. So the simplest implementation of this is just to have return producer config. Yeah, so you can actually test this if you want to write unit tests for that. So but basically you get the point. So I just go back into this and I'm going to put a topic here, and the topic is going to be, let's call this super productive website logs. Maybe I'll call it billion. Yeah, billion website logs, whatever you call it, it doesn't matter. It's just to get the data into the topic. So this is where it gets interesting, because we're going to be using Apache Airflow and we want to schedule this to be running at some interval. Then it gets a little bit tricky, because you don't want to continuously produce data, because if you do that, then your Airflow instance just keep running. For some reason it can fail. So for the sake of this video, we're going to be producing the data at intermittent interval, more like every 5 minutes, just like we scheduled. So what that means is we produce some records that is going to be maybe for that 15, let's say 15,000 records or 150,000 records. So once that gets once that gets produced, it gets shipped into Kafka, and in the next 5 minutes another one gets produced, and every 5 minutes interval, you're going to be having 15 of 150,000 records in Kafka. The same way, if you want to index the data, you're going to be indexing as they come along every 5 minutes. Yeah, so that's the way we want to do it. It's not real time, but it's not super batch. Well, it is, but you get the point. All right, so let's continue. Okay, so going back to this, I'm going to have in my code here, I'm just going to have how many ranks you want to have. I'm just going to have 15,000. If you want to increase it to 150,000, be my guest. Then we have generate log, and this is where the actual implementation of the log comes in. So we're going to have a function that helps us to generate the logs, and we have dev generate log, and this is going to generate a synthetic log. So if you have some DB or some access files or some log files that the logs have been saved in, you can actually read from there and push to Kafka from here. So because the absence of that, we don't have anything like that. So we just have our methods. We have post, we have put, and we have delete. Yeah, these are the options that, or the API methods that we're going to be using. So we have the endpoints that we want to use. So let's say for the backend, we have API users, we have /home, we have /about. People wants to know about you. You have /contact, maybe /services as well. It can be as many as possible, or for randomization's sake, you can increase it, but in our case, I'll just leave it as it is. For the statuses, I'm going to get the status here as 200, 301, 302, 400 for bad request, 404 for not found, 500 for internal server error, then 200 for OK, 301 for redirection, 302 for permanent redirection. So you have user agents. It's going to be the agents. In this case, I'm going to have Mozilla 5.0, and it's going to be, let's call it iPhone. Yeah, CPU is going to be iPhone OS, and it's going to be iPhone 14, and it's going to be like Mac OS. Yeah, because the operating system. Yeah, let's leave it at that. That might not be the way it works, but you get the point. So let's call this Mozilla 5.0 as well, and it's going to be X11, and this is going to be a Linux phone. Yeah, Linux x86 _64. In actual sense, we can actually employ the services of our Copilot to get us more. So let's say we want to ask it to get us more, and going to have Mozilla Macintosh, what else, Apple. Yeah, that's good. That's getting our money worth. Let's add one more. I'm going to just have this. Good. So let's have that. We have our user agents. I'm just going to disable it again. Then the referrers. It's going to be where the traffic is coming from. I'm going to have https example.com. Then we have google.com, https google.com, and then maybe Binge as well. In fact, let's just employ the services of our Copilot to help us with that. Bing, then yahoo.com. Good. So these are our referrers. I'm just going to disable this. Now, once we have our referrers, the next thing will be to generate the keys that we want to put inside our log. So we have IP is going to be fake.ipv4 version 4 rather. We have timestamp. It's going to be what time the activity happened. So we have datetime.now, and then we change this to strf time, so we can easily format this and generate the right formatting for our data sets. and for indexing purposes as well. So we have BD here, and then we're going to have hours, minutes, and seconds. Hours, minutes, and seconds. Good. We can now have a method which is going to be a random.choice from methods, isn't it? We have endpoints. It's going to be random.choice from endpoints as well. The status is going to be, I'm just going to change this. Yeah, status is going to be random.choice from that choices. Statuses, yeah. Then we have size. It's going to be random.randint, and we want to know the size of the request, yeah. So it could be between 1,000 and maybe 15,000. Then the referrer is going to be random.choice, then the referrers. Then finally, user agent is going to be random.choice for the user agents. Good. So you just pick any from there. So for the log entry, the way the logs is going to look like, if you've probably checked Nginx logs before, this is going to try and mimic that. We are going to have something similar to this, where we have IP address, then dash the timestamp. Just going to put this timestamp inside the bracket here, timestamp, and then you have the method. So it's going to be backslash full quotes. We're using single quotes, yeah, so it's fine. So single quotes, the method, then the endpoint, then you have HTTP 1.1, then the status is going to be method, yeah, endpoint is going to be that. Just put this next to this. Then you have status, then the size. You can have the referrer as well, so inside a string referrer, and then you have the user agent. Good. Let me see, are all this correct? IP address, yeah, the timestamp, the method, and the endpoint, and the secure, and the request type in double quotes, data size, referrer, and the user agent. Good. So that's our log entry that is going to be used to create that. We can just say return the log entry. So this is going to generate a log for us. So now going back down, we're almost there. So log is going to be, let's try to generate the log and produce that. Producer.produce into the topic that we've just created. Then we encode this in UTF-8 format. Then on delivery, we want to get an acknowledgement message on delivery. It's going to be, let's get it delivery report. Delivery report. Yeah, we don't have a function called that, so let's create a function to do that. So dev delivery report. In fact, just quickly do that with Copilot. Delivery report, error message, and boom, that's it. So that's our delivery report. Usually, let me just check to make sure that the code generated is right. So in the delivery report, you have, yeah, that's fine. So you get topic and partition, which is good. So now that is good. So we have producer done. Here we can just say produce that or produce. Yeah, so flush rather. So to make sure that the message gets delivered. Then if there's an error, you just say error producing that, and you can raise the error, which is good. So at the end of the day, just say produce 15,000 records, logs into the topic. And I believe that takes care of everything that we need to do. But for posterity's sake, let me just check this and make sure that everything is good. So you have the logs. So what I'm going to do is try and print this out. Try and produce this directly and see what that look like. Now, before I do that, on my Confluent Cloud, I go to my topic and create a topic that's going to host this data. So billion topic is going to be this, and partition is going to be six partitions. So if you want to enable infinite retention, bear in mind you can toggle that on and off. So I'm just going to create that with default. So if you want to enforce a data contract, which is the schema, a fancy way of saying schema, so you can use the schema registry in this case. We are not going to enable that for now. That is not applicable to our use case. All right. So once that is done, we have billion websites logs that we can use. So before we deploy this to production, we can easily test this out and see if it is working just fine. All I need to do is comment this out and then call the produce log and see if I can run this log producer. That will be inside DAG's logs producer, and change this to, let's rename this. Yeah, let's see if it produces any data at all. So it says it delivers some data in there. So we have how many records? Into 34343, yeah, 245. So we should have 5 records produced into this topic. So let's see. So in our production, do we have anything? 6 records. Good. So we have 6 total messages that have been delivered, and we can go from beginning. You can see them here, which is good. So it looks like everything is working just fine as expected. So you have the IP address and the way it should be as it is. So we can now confidently say we are producing the data as expected to Confluent Cloud. So what we need to do now is go back and start before we deploy this, we get the consumer as well. So we consume both and deploy at the same time. But if you want to keep producing this while the consumer gets ready, you're all well and good. But I want to do the same at the same time. So, so now we have our logs producer. For the consumer, we need to just have a separate consumer here and create a new file. We call the file new Python file. Let's call it logs processing pipeline. And in this pipeline, you can have your consumer. So you have from datetime imports datetime and time delta, because literally the same thing, except that the logic is a little bit different in the sense that one is producing, the other one is consuming. So I just disable our completion here. So we say we import drag, and then we say from airflow the operators the Python. Let's import the Python operator. Then of course we're going to be needing the Confluent Kafka. So from Confluent Kafka, import consumer and Kafka exception. And the reason for that is we're going to be consuming data from Confluent Cloud, and we need the same parameters that we used here. Then we need to connect to Elasticsearch as well. From Elasticsearch, import Elasticsearch. So yeah, that's fine. Import JSON, import login, and import both03. Yeah, so because we're going to be connecting to that. For now, let's leave it at that. So let's get our logger in place. So logger equals to login.getLogger, then the class name. Good. So that's the first thing. The second thing is to get our logs producer. So if you prefer to put this, since it's going to be the same thing, you can actually put this in a separate file and call this let's call this utils. Yeah, utils, and move this so we don't repeat the code. And here import both03, import JSON, and import logger. Logger equals to login.logger. Then we get in our name. Yeah, so that takes care of that. And then in our producer, we can just import our secrets, dark utils, You can just say .utils and we're good to go. And here, the same thing for log processing pipeline. We can just get our secret from there, so we don't have to do that multiple times. Now let's get our DAG to help us have an entry point into the picture. So we have an entry point here, which is going to be copied. So we have logs consumer pipeline here. Then the default argument comes into the picture. So let's get in our default argument, default args, and yeah, literally the same thing. Now except that instead of producing, we say consume and index logs. Yeah, at the end of the day, and change this to consume logs tags. Just put it here. This is not necessary because it's just a single task anyway. So yeah, let's create a function here. So call this, what's it called? Consume and index log, and get in the context into the picture. Good. Now for us to do that, consume and index log, we just say get in our secret. So secrets is going to be get secret, which is coming in from dag.utils. I think I prefer to do .utils, which is because in the same class. So .utils and then MWAA secrets underscore v2. For our consumer config is literally the same thing as we had in the producer. So I'm just going to copy that over. Just copy this. Just fine tune this a little bit. So we have our bootstrap server, which is the same. Security protocol is the same. SSL mechanism is fine. Username and password is okay. Now we just need to change this to a little bit different syntax. So we just change this to group ID because this is what we need. We need to give this a group ID. So let's call this MWAA log indexer. And then where do we want to start from, which is going to be starting from where. So we have auto.offset.reset, which is going to be the latest. So you can actually start from the latest or the offset. Now the only downside that is there is if you use the earliest in this case, each time you run your consumer, it's going to always start from the beginning, which is not usually what you want. You want to start from the last time you stop, which is the latest. So if you stop at, let's say, offset 1000, the next time it starts, it's going to start at 1001. So it's not going to read the 0 to 1000 that you already did before. So yeah, so let's go into that and see what the rest of the code look like. So going back here, you have consumer config. Okay, now we can just create our Elasticsearch connection. So we have ES-config. So let's connect to Elasticsearch. So we have our host as a key. It's going to be secrets Elasticsearch URL, just like we had in there, comma, and then API key, which is the key that we use to connect to that. We have secrets and Elasticsearch API key. Now with that said, we can now have our consumer, which is going to be consumer and consumer config, which is the configuration that we set earlier. Then once we have our consumer config, we use that to then we connect to Elasticsearch with the config, ES-config, which is the host and the API key. Yeah, the topic we are consuming from is going to be what topic? Billion website. And then the consumer is going to be to subscribe to that particular what topic. Good. Now what happens is, before we start consuming, we need to make sure that this particular index exists. If it doesn't exist, we need to create it. And the reason why is simple. If you try to produce to an empty index or a data stream, it's not going to go ahead and do that. Because unlike Kafka, if you don't have a topic, it automatically creates it. Now, if you don't create the topic with Confluent Cloud, especially in production, it's not going to work. It's just going to keep trying to send, but it's not going to work. What you need to do is create a topic first, then produce into it. The same way on Elasticsearch, you create the data stream or the index first before you produce data into it. Hope that is clear. Okay, so let's go back here. So we have consumer that we're subscribing to. Then we say our logs that we want to use in this case. So the reason why I'm putting this in here is I want to before I put the logs, I think I need to create a data stream first. So let's do a try except rather. So we have a data stream name, which is going to be, let's call this billion website log. Yeah, billion website logs. Yeah, that's fine. We can use the same name as it is. Then, if we don't have es.indices, if you don't have that index existing, which is going to be index of data stream name. In fact, it might not be data stream. This is just the index, yeah? Index, not really a data stream in this case. So if it doesn't exist, then we create it. es.indices.create. And the index name is going to be, in fact, I'll just call this index name, so we don't mix it up with the index. Yeah, index name. Good. Then once we have the index name, we have logger.info, and then we just output something called created index of index name. Good. Now let's undo the exception. Except exception as e. We can say failed logger dot error, failed to create index of index name. Good. So while that is done, we now have potentially we have an index created on Elasticsearch. It said 2 brought exception clause. Well, that is your problem. I want to handle everything in there, so it's okay. Or probably, why don't we just put everything inside the same try catch block, so it's easier. But the only challenge with this is if something happens, we might not know exactly what went wrong. So let's have a separate try except block. Exception as e, and logger.error, failed to index the log. We're going to come back to this much later. Call this E, yeah? Good. Now let's go back here. Just put this here instead. Okay. So in my try block here, I'm going to have my logs. The reason why is I want to batch this up. So to say every, let's say 1,000 or 15,000 record, batch this up and index them in batch. Okay. So while true, so we just want to continuously do this. Message is going to be consumer.poll. So we wait for request from our Kafka for 1 second. So if there's message, if there is no message, rather, if message is none, break it. Otherwise, if there is message, in fact, let's check for error. So if message.error, then we say if message.error.code equals to Kafka exception end of partition. I'm not sure exactly. I hope this is right. Partition EOF end of file. I might need to check the syntax to be sure. I need to check. Break. Otherwise, you raise Kafka exception. Raise Kafka exception with the message.error a message dot error. Yeah. So once you raise that, you have your log entry. So you have log entry. It's going to be message.value, and then you try to decode that UTF-8. This because when you encode it, UTF-8 it's plain string anyways, but you can decode it as well, so it's fine. So we can easily pass the log. Passed log is going to be pass log entry and the log entry. Now, what's going on here? So we consume the data from Kafka, and if anything happens, we raise an exception with Kafka exception. Otherwise, we decode the message that is sent into Kafka, and then we pass it. And the way to pass it is simple, because it's simple when you are producing. We are producing this log. Where are you? Yeah, we're producing this. So we can easily decode this by writing a simple regular expression that helps us to decode that. So we can do that by just coming back to the processing pipeline. Just above here, just write something here and call this dev pass log entry. Yeah. And then the log entry is going to be here, and we write a simple regular expression to do this. So the pattern is going to be log pattern. So we have a regular expression of open brackets, then we have question mark, which is P, and then IP. So to extract the IP address, and the IP address looks like a decimal number, yeah, dot at the end of the day to the end plus. So we read the IP address in there as with this. We just use this to read the IP address. Then we say dash dash, yeah. Then we read the second one, which is the timestamp. Then question mark P, and then we say this is the timestamp. Timestamp is correct, yeah. Dot asterisk, then question mark, and with this we have our timestamp, and we need to open a bracket before this, so we just like we did before here. So we open and close the bracket, then P timestamp / add full stop asterisk to the question mark. So that reads the timestamp for us. We do the same for the method. Maybe just copy this. I'm just gonna copy this. Copy. Oh no, that's inside a string. Yeah. Let me see. We have our endpoint. Is it? Method is here. Method endpoint and HTTP one. Yeah. So it's gonna be open bracket question mark P method. Then it's a word W, and then we have the next one as endpoint. Literally the same thing. Question mark P endpoint, in this case endpoint, and this is going to be W / that. So you can just let if you don't understand regular expression, or you don't understand what I'm trying to do, you can easily just let or read about regular expression, or just leverage some other approach to read the regular expression. If you want to dump it directly as it is, it's also fine, but I'm not going to be doing that. To full stop, close the bracket, and then plus. I think that should be fine. I have word / backward, yeah. So that's fine. So I read the IP address, the timestamp, the method, the endpoint, and the protocol. Is it timestamp, IP, timestamp, method, endpoint, and protocol. So we still have size and referral. Those will be automatically done as well, because they are just as it is HTTP endpoint, so it's good. So we just say match. It's going to be read.match, yeah. The pattern is going to be log pattern, and the log entry. So if there's no match, if not match, then logger dot warning is going to be invalid log format for the log entry. Good. And we can return none. Now so that's it. We just, if it now matches, in this case, if it doesn't match, but if it matches, we just extract the data, which is going to be match.group dictionary, and try to assign the timestamp and all that to that. So we say past timestamp. It's going to be past timestamp. Yeah. It's going to be datetime.strp time. We extract data timestamp from there, and that's why we're putting them in the variable in the regular expression. So we're expecting b d y in the same format, then hour, minutes, and second. Yeah. Then you have data. It's going to be at timestamp. It's going to be past timestamp.iso format. So except value error, logger.error, timestamp passing error, and the data is going to be timestamp. So we put this as a double quotes, timestamp. Yeah, that's fine. And we can just return none here. So what's going on here? So I'm extracting the IP address, the timestamp, the method, endpoint, protocol in here, and putting them directly inside a dictionary. So what that means is inside this variable, we're going to have individual item as a key value pair that is read from the log. So we can just go back here at the end of the day. Once everything is fine, return the data as a JSON object, and we can continue our coding. So once we pass the log, the next thing will be to easily, and from here, try to index them. Yeah. So at the end of the day, if passed log, logs.append passed log. Now the reason why I'm appending this is at some interval, like I said, I want to index them in bulk. Yeah. So we're going to be indexing when no, I need to comment this. So index when 15,000 logs are collected. Yeah. So easily we say if the length of logs is greater than or equals to 15,000 or 150,000, the actions is going to be operation type on Elasticsearch is going to be create. The index is going to be underscore index, is going to be the index name. Then we have underscore source, it's going to be the log. So what happens is, let's see, yeah, it's going to be log. Yeah. Then we do a for log in logs. Yeah. So what that means is I'm looping through the logs, then indexing them with individual item in here for the actions. Then I can put this inside a bulk operation for my Elasticsearch. So I say if there's a success or failure, which is failed, it's going to be bulk. So we just import Elasticsearch helpers bulk. We say Elasticsearch the actions and then refresh, so to get the status. Okay. Elasticsearch actions. What's this? If, yeah, I think I need to put this inside. Yeah, that's it. So if the length, yeah, that's good. I was running it outside before. So logger.info, we say indexed success, the number of successful log, then the number of failed. Yeah, so in this case, length of failed and logs failed. So we import this successfully and this failed, if there's any. Then we reset the logs. Okay, so that's what we're doing basically. Again, to go through and recap that, we can connect to Kafka, pull the consumer data, we pull the data from Kafka in here, pass it with regular expression, then convert it to dictionary with that, and then if it exists, then because we already passed it, we put it inside a log, and after 15,000 records are collected, we index them in bulk, and then we rinse and repeat, then reset the logs here. So basically that's what we're doing, and I think that's fine. Okay, so let's move this outside of there, and we should be fine. Now if there's any logs, just in case there's remaining logs, index any remaining log. For some reason, if there's anything left inside the logs after indexing, maybe there's indexing takes a little bit more time, then we need to repeat the action in here. So I'll just do the same here. We repeat the action for the operation, create for the index name, the logs for the data inside the logs, and do the bulk again. Bulk, yes, actions, and then refresh equals to true. Okay, and I think it's probably best at this point to wrap this as well in a try except exception as E, and say logger.error, call this log processing error. Okay, fine. I think that's fine. So once that is done, we can just say finally, if everything seems fine, consumer.close, and close the connection to Elasticsearch, es.close. It closes automatically, but for best practices sake, we close that as well. Good. Now once this is done, we can now go to Elasticsearch and create our index. So going to Elasticsearch here and going to indices, I'll create a new index. I'll call this billion website logs and create the index. Once the index is created, we are waiting for the document count to start increasing, and you can also view the document once that is done. Now before we deploy this to our DAG, we can also confirm if this is working. Consume an index log. Hopefully everything should be fine. It doesn't look like we need all of this. Yeah, let's see. If everything seems fine, then we can log processing pipeline. Let's see if there's any error. So it says it couldn't find the parent package. Yeah, so I think it's probably because I don't have init here. .py, is it? Yeah, let's check again. dags.utils. For some reason, I'm skeptical about this in production, but let's see. It says no module name dags. So what I'm going to do, I don't know, I'm not ready to debug all of this, so I'm going to just move this back into the code just put it somewhere here, and thank you. You can go away. I'm not ready to start debugging anything for now. And in my log processing as well, I'll delete this and put the function here. I know it's a repetition, but you know, to avoid this video getting too long, so let me know how you fix that in the comment section. So I'm just going to leave it as it is and go to the terminal again and rerun this. Okay, it says non-type has no value, and it was not able to index the log. Let's see why. What's our log name here when we are logging? Yeah, billion website log is our topic. So do we have any data here? Consumer.poll failed to index log. Okay, non-object has value, so it looks like it's this message, the value, that is the problem. So what are we doing wrong? So we said consume this here. If the message is none, break. If the message is error, break as well. Then the log entry is going to be in here. So I think it's because we put this in outside of the while loop. So I'm just going to move this one step, and it should be in the same loop as that. That should be fine now. So he said SASL mechanism break. It says broker does not support it because the SASL mechanism handshake failed. So it's probably because I'm not running in HTTPS. But that shouldn't be a problem, should it? Let me see. So let's check the configuration again. We have bootstrap server. We have SASL plain, the secrets. Then this is fine. So I'll just leave this as it is. But the good thing is we're able to connect that. So by the time we get to AWS, we should be able to automatically do this without issue. Probably because I'm running on my terminal. That's why. If I run this on on my what's it called? If I run this on Apache Airflow, it should be fine. In fact, let's do that. Let's do that. DB init. Then migrate. That should create. Okay. Yeah, then we can migrate. Well, I don't know why it's not working, but I'll just leave it as it is. So Airflow web server, and I'll create another one here. Airflow web scheduler. So let's see what that look like on Airflow before we deploy this, because it's easier to 8180. I don't have a username and password created, so I'm going to just Airflow users.create and create a password for Scholar, and that should be fine. Okay, I have a couple of them here, so I just disable that. Load examples, it's going to be false. Then restart my scheduler. That should clear it out. Good. So I have my consumer pipeline and my generation pipeline. So let's check this out and see if this is working. So if I enable this, I'm saying it's trying to generate and produce logs. That's the consumer, isn't it? So that's wrong. I think we fixed that in here, because it's supposed to just be generate and consume log, not produce. Consume log, consume and index synthetic logs. Okay, so it's running. So let's see if we are able to see any logs generated. So I guess we just have to wait a little bit. But the problem is it's going to wait for 15,000 records. So yeah, so we need to enable our generation as well. So I'm going to just stop the scheduler and rerun it again. Okay, so that is running. I'm just going to mark this as successful. So only one just is running. Yeah. Let's see, do we have any logs created? Not yet. So let's check our Confluent Cloud. Do we have any new records? So nothing is produced yet. Address is already in use. I don't know why. I'm just gonna stop this too. So what address is that again? 8793. So I'm just gonna kill it. Okay, and then run the scheduler again, run the web server again. So let's see. So he tried 2 times and it's still not working. So my scheduler is obviously having a problem. So what I'm going to do is just ignore this and deploy this to production. Then we fix it from there. It looks like it just doesn't want to work here. So I'll just leave it as it is. And now, so let's have Git init. So I'm just going to get my initialization in here so we can have our inits in there. Then touch.git ignore. In my git ignore, just going to have this pasted here so you can exclude unnecessary here. So if I check I have my DAGs and my web server config. I don't need the web server config as well, so I might as well just exclude that from there. So I have my DAGs and git ignore that is there. So I just git add. So I'll say MWAA project setup. Good. So I can go to my repository now and create a new repository. So if I go to GitHub and just create a new repository here, I'll call this MWAA production. Yeah. Then it's going to be private, create repository. I'll copy this as a SSH, copy this out, and then GRA origin, and then GGP. If I push this to my repository, I have the repository here. The good thing is now we have the first step in this entire giant spider web. We have the first step in place. So the first step is to have the code, and it's tested, working. We tested it with Python. It worked. The production worked just fine. It's just that with Airflow it didn't work just fine. So all we need to do now is find a way to synchronize this to AWS. So to do that, we just need to have a workflow. Each time we push the code, we are going to synchronize it to our AWS. But to do that, you need to go back to AWS and extract the credentials, the security credentials from there. So because I'm a federated user here, I may not be able to use it. So I need to sign out and switch my account. So I'll do that, and this account will change. Just need